Welcome to the notes on transversal lines and corresponding angles. So first we have two vocabulary words, which are the title of the notes. The first one's transversal line. And what a transversal line is, a line that crosses two parallel lines. So if you look here, line LM is parallel because of these two arrows to line NP because it also has these two arrows. And parallel means they never cross. And then line JK, this guy right here, I'm going to highlight it. JK is the transversal because it is the line that is crossing the two parallel lines. So the second vocabulary word is corresponding angle. It sort of got printed over here by accident, so go ahead and just scribble that out and write the word angle next to corresponding. That's one word or one term, corresponding angle. And first I'm going to write the definition, and then I'm going to explain what this means. But a corresponding angle is an angle on the same spot on the transversal. So for this to work, you have to have two parallel lines. And then if you look at A is up in the upper left-hand corner of the four. And then if I look where the transversal cuts the other parallel line, W is in the same spot that A is up here. So A and W are corresponding angles. So like I'm going to put like maybe a dot and a dot because those two go together. They're corresponding angles. They have that relationship. So a corresponding angle is one of our angle pair relationships. Like we had straight line pairs and vertical angles. Now we are adding corresponding angles. And these are two angles that are at the same spot on a transversal. So if you look at B, it's in the upper right. The other thing, if I move down the transversal and hit the next parallel line, the thing in the upper right hand corner is the X. So I'm going to put like a circle here. Those two are the same. At least they're corresponding. Now angle C is in the bottom left, just like angle Y is right here. So I'm going to put like two lines for this one to say they're corresponding. And finally, angle D is in the bottom right hand corner of these four, just like angle Z is in the bottom right hand corner of these four. And for this one, I'm going to put a triangle, just so you know which ones are corresponding with each other. So, remember every single relationship we had, there was a way that we could describe that relationship. And the descripting word for corresponding angles, if you look at A and W, if you had to guess if they were complementary, which means add to 90, supplementary, which means add to 180, are congruent, which means they're the same, which one do you think corresponding angles are? Well, the answer is that corresponding angles are congruent. They are the same. So if A is 50, that would make W 50. Because they're corresponding angles, that means they are congruent. So, I promised you that everything I told you, I'd prove to you why it was true. However, for corresponding angles, there isn't a proof. It's something called a postulate. So see that bolded word? And what a postulate is something so basic, it has to be true. So sort of a postulate is that a triangle has three sides. And the reason why it's a postulate is because if you look at a triangle, you can just count them. And there's no need to prove that because it's so basic it's true. And so the fact that corresponding angles are congruent, the reason why it's so basic that it's true, and so this is the why part, is because if you have two parallel lines, they are running in the same direction. And so when the transversal hits it, whatever angle it's hitting it at here, it's hitting it in the exact same angle down here. Because it's like they're practically the same line. They're not the same line. They're definitely, this one's much higher than this one. But they have the same angle. And so when a different line's hitting two lines that have the same angle, it's hitting them both in the same way. And so wherever it's crossing right here, the same thing's happening as over here. So here's why it's so true. With two parallel lines, the angle of those lines are the same. So when a third line crosses them, and that's known as the transversal, it is hitting it in the exact same way.